Let's graph a higher order function using the leading coefficient test and multiplicity. Let's get started. Consider the following function. H of x equals 5x squared times the quantity x plus 9 cubed times the quantity x minus 8. So here we go. So we needed to figure out the degree of this function. So we consider the powers on all of the factors. We have a power of 2 on x, a power of 3 on the quantity x plus 9, and an understood power of 1 on this final factor. So when we add those powers up, we will get a 6. So the degree of this function is 6. That is an even degree. Not an even function, but an even degree of the function. Whenever you have even degrees, the end behaviors will do the same thing. Think of a parabola. When you have a parabola, if the leading coefficient a is positive, then both ends will rise. Rise on the left, rise on the right. If the leading coefficient in a parabola is negative, then both ends will fall. The parabola will open downward, both ends fall. So that's the case with all even degree functions. Both ends do the same thing. Positive leading coefficient going up, negative going down. So we have a positive leading coefficient and we have an even degree. So on the left end of this graph, as well as the right end of this graph, the end behavior rises. Rises on the left, rises on the right. So when we go to answer part A of our question, we're looking for options where it rises both to the left and to the right. So we would choose part B, choice B. Okay, now moving on, they want us to find the x-intercept. The x-intercept. So let's do it. X-intercept. They're always in the form of this ordered pair. You will have some x value and the y value will be 0. That's how we get x-intercepts. So let's take this function, and in place of f of x, we know that this h of x is really y. So we're going to let this y equal 0 and solve for x. 0 equals 5x squared, x plus 9 cubed, x minus 8. So we already have factors. It's in the factored form. Okay? So we're going to set these factors equal to 0. Anytime you have a product and the final answer is 0, one of these factors, if not all of them, would be 0. So we're going to say 5x squared equals 0, or x plus 9 cubed equals 0, or x minus 8 equals 0. The last case is very simple to solve. We're going to add x8 to both sides, and we get x equal 8. That's one of the x-intercepts. Okay, it's positive 8. So in order to eliminate a cubed power, we're going to have to take the cubed root. And what we do to one side, we do to the other side. So the cube power and the cube root cancel each other out, and we're left with x plus 9. The cube root of 0 is 0. And then we subtract 9 from both sides, and we get x equals negative 9. That's another x-intercept, another root. And finally, we're going to get rid of times 5 by dividing both sides by 5. That leaves us with x squared. 0 divided into 5 equal parts is still 0. And now, to eliminate a squared power, we're going to take the squared root. And whenever we take the square root, we bring in our own square root symbol. We have to bring in plus or minus. Square root, square power becomes a power of 1, or simply x. The square root of 0 is 0. 0 is neither positive nor negative. It's just 0. So now we have our 3 x-intercepts. And the problem wanted it in a comma-separated list. If we wanted to, we could list this in ordered pair. Remember, we allowed y to be equal 0. So in all of these x's, the other part of the ordered pair would be y equals 0. X equals -9, y equals 0. X equals +8, y equals 0. Those are my 3 x-intercepts, or roots, or zeros. And so when we go to answer the question, we will list the answer how it is requested. The x-intercepts are 0, -9, and +8. Next, we're going to talk about multiplicity. So the question is the multiplicity of the least x-intercept, of the greatest x-intercept, and the others. So we need to focus on the x-intercepts, and we need to order them. So of these 3 x-intercepts, 0, -9, and 8, the smallest one is this -1. X equals -9. The greatest one is the positive one, 8. X equals 8. So then the other one, neither least or greatest of the 3, is 0. And now, what are the multiplicities of those different zeros? We have to go back to their factors. We got the 0 from x squared. Squared is even. So we can actually, on the 0, list exactly what it is. It's not asking for odd or even. It wants the exact multiplicity. So on 0, the multiplicity is 2, coming from x squared. Now, from -9, we had a factor of x plus 9 cubed. So the multiplicity on this 0, or x-intercept, is 3. And from 8, we had a factor of x minus 8. So that was an understood multiplicity, power of 1. Now, F, G, and H, now we want to take those same x-intercepts and determine how the graph of H is going to interact with the x-axis. So let's highlight. We're looking for the least x-intercept, the greatest x-intercept, and the other one. Again, of the 3, the least is the -1, -9. Greatest is +8, and the other one is 0. So at -9, since it has an odd multiplicity of 3, the multiplicity we found in the question above was 3, that's odd, it's going to cross the x-axis. The x-intercept 8, we found the multiplicity to be 1, that's odd as well. It will cross the x-axis at that x-intercept. However, 0 has a multiplicity of 2, that's even. So it will, the graph of H will touch the x-axis at 0, at the origin, and turn around. It will bounce off of that x-intercept. Now the problem requests that we find the y-intercept. So let's do that. Y-intercept. So the y-intercepts will be of this format. X will equal 0, and we will have some y value. So let's rewrite our function h and let x equal 0. So we're going to start out with y, and everywhere there's an x, we are going to substitute in 0. 5 times x squared, 0 squared, open x plus 9, 0 plus 9, quantity cubed, x minus 8, 0 minus 8. And so we get to clean this up and solve for y. So y equals 0 squared is 0. 0 times 5 is 0. 0 times this quantity, whatever it is going to be 0. So since one of these factors is 0, it's going to zero everything out. If you have to see it, we can write another step. 5 times 0 times 9 cubed times negative 8. All those numbers multiplied by 0, we're going to get y equals 0. So in went x equals 0, and out came 0 for y. Input 0, output 0. So that is the origin. If the x-intercept involves the origin, you're guaranteed to have a y-intercept at the origin as well. That's where the two axes intercept. So when we answer our question for this problem, we want to make sure we list for part I, and this time they want us a ordered pair format for our answer. The y-intercept is 0, 0. Next, part J wants us to determine if h of x is even, odd, or neither of the two. So let's do it. We take our original function and we decide if we can replace x or y with a negative, and if we get the same function back. So remember, here's h of x. We can write it as an equation, and we can replace y with negative y and determine if we're going to get the same function. So y with the negative y, and if everything else remains the same, this does not simplify into the original function, okay? Then we replace x with the negative x. So we start out with y, and everywhere there's an x, we're going to replace it with negative x, okay? And so here, I can square away the negative, and that's going to take me back to that original factor. But that's not going to happen with the rest of the factors. So this is not going to take me back to my original equation. This negative that I inserted is going to remain. And the same with the other one. So this function is neither odd nor even. So when we answer the question for part J, we choose neither. And now, reflecting back on all of the information that we computed about this problem, we should be able to graph this problem. First of all, I know what my zeros are. Let's recap what our zeros are. The least one was at -9. The greatest 0 was at +8. And somewhere in between the two, the other one is at 0. And we got this from the factor x plus 9. And that factor was cubed. So it had an odd multiplicity. And we got the 0 from the factor 5x squared. So that factor, that 0 has an even multiplicity. And here, our x-intercept of 8, we got that from the factor of x minus 8 to the first power. So the multiplicity there was odd. And the leading coefficient said that both of our endpoints were rising to the left and rising to the right. Our end behavior of the graph, both end behaviors were rising. So since this is odd, the graph of h will go through that 0 with an inflection because of the cubed. We call it a little squiggle. It goes through it in that fashion. It goes down to some relative minimum. It turns around and interacts with, and this is just a sketch, we don't know how far it goes down. It interacts with this even multiplicity. It will not go through it. It will touch it and turn around. And again, it will go down to some relative minimum and turn around. Okay, so we're looking for a graph in part K that kind of looks like that. I can use process of elimination to go ahead and eliminate choice A because the end behaviors both fall to the left and the right. And that's not what I'm looking for. I can also eliminate part D. Both end behaviors fall. That's not what I'm looking for. So it's out of B or C. So now let's look at how the graph interacts. And again, this is a sketch. I know that there's a 0 x-intercept. There's one at -9 and +8. And what we have happening, if we look very closely, this is saying -8. Let's count 0, -1, -2, 3, 4, 5, 6, 7, 8. This is at -8. And that's not what we're looking for. We're looking for our -0, our negative x-intercept to be at -9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right here. Okay, and then +8 on this end. 1, 2, 3, 4, 5, 6, 7, 8. So C is the correct choice. So a quick change. This last 0, the graph does not proceed through it in an inflection way, although it is an odd multiplicity like the first one. It's odd in a linear way. This is a multiplicity of 1. This is a multiplicity of 3. So with the odd multiplicity of 3, the graph proceeds through with an inflection. With an odd multiplicity of 1, the graph proceeds through in a linear fashion, matching what you see in choice C. Proceeding through in a linear fashion, proceeding through in a slight inflection.